Hello, today we're going to dive into a powerful concept in algebra, the binomial expansion. By the end of this video, you will be able to use the binomial theorem to find specific coefficients within an expanded binomial expression. Specifically, we're going to tackle a common type of problem: finding the coefficients of specific terms, like x squared and x cubed, without having to write out the entire expansion. This is a huge time saver. First, let's understand what we're talking about. We want to expand an expression like this. It's a binomial raised to a power. In this case, the expression 2 minus x is raised to the 6th power. Now we could try to expand this by multiplying it out 6 times, like this. But, as you can imagine, this would be a tedious and error-prone process. The binomial theorem gives us a much more elegant way to find any specific term we want. So what is this powerful tool? It's called the binomial theorem. The binomial theorem provides a formula for expanding binomials of the form a plus b raised to the power of n. It tells us that this expansion is a sum of terms, and it turns out that each term in the expansion follows a predictable pattern. Let's write down the general term. This formula gives us the k+1th term. It looks a bit complicated, so let's break it down piece by piece. Let's deconstruct that formula. T sub k plus 1 equals n choose k times a to the power of n minus k times b to the power of k. First, we have the term in choose k. This is a binomial coefficient, often represented like this, with the n on top and the k on the bottom in parentheses. This value, also written as c of nk, tells us the number of ways to choose k items from a set of n items without regard to order. You can calculate it using the factorial formula. N choose k equals n factorial divided by k factorial times n minus k factorial. Don't worry, the formula will be provided. This coefficient is the number that comes before the variables in our term. It's the number we are trying to find in this problem. Okay, let's connect our problem, expand 2 minus x to the 6th power, back to the general binomial theorem. Remember, our expression is a plus b to the power of n, and our specific problem is 2 minus x to the power of 6. By comparing these two forms, we can identify the values for a, b, and n that we'll use in our formula. In this case, n, the power is 6. The first term, a, is 2, and the second term, b, is negative x. It's crucial to include that negative sign. So we're finding the terms in the expansion of 2 minus x to the power of 6. Let's start with the coefficient of x squared. Our goal now is to find the coefficient of the x squared term. Let's use the general formula we saw earlier. We know n is 6, a is 2, and b is negative x. We need to find k. Let's substitute our known values into the formula. This gives us the k+1 term in our specific expansion. Now we can rewrite this to group the numbers and the x term separately. Remember that x to the k is the same as +1 to the k times x to the k. Rearranging the terms, we get this expression. Notice that the exponent of x is simply k. We're looking for the x squared term, so we need the exponent of x to be 2. Since the exponent of x is k, this means k must be 2. So we found our value of k. For the x squared term, k is 2. Now we can substitute 2 for every k in our formula. Now we're ready to calculate the x squared term. We use our formula with k equals 2. Plugging in n equals 6 and k equals 2, we get t sub 3. Let's calculate the components. First, the binomial coefficient, 6 choose 2. Remember the formula. This is 6 factorial divided by 2 factorial times 4 factorial. Expanding this out gives us 15. So the numerical coefficient is 15. Next, we have 2 raised to the power of 4. 2 to the 4th power is 2 times 2, 4 times, which equals 16. And finally, -1 squared. -1 squared is +1. Now we combine all the pieces. The coefficient is 15 times 16 times 1, which equals 240. So the x squared term is 240x squared. The coefficient of x squared is 240. Great work! Now let's use the exact same logic to find the coefficient of the x cubed term. It's really just a matter of repeating the process. Again, we start with our general term formula for this specific expansion. This time, we're looking for the x cubed term. What does that tell us about k? Since the exponent of x is k, for the x cubed term, k must be 3. Now we have our new k value. With k equals 3, let's calculate the x cubed term. We're finding t sub 4, so we plug in 6 for n and 3 for k. First, the binomial coefficient 6 choose 3. This is 6 factorial divided by 3 factorial squared. Calculating this gives us 20, so the numerical coefficient is 20. Next, we have 2 raised to the power of 3. 2 to the third power, or 2 cubed, is 8. And finally, negative 1 cubed. Since the exponent is odd, negative 1 cubed is negative 1. Now we combine everything. The coefficient is 20 times 8 times negative 1, which is negative 160. So the x cubed term is negative 160 x cubed. The coefficient of x cubed is negative 160. Let's quickly recap what we've accomplished and the steps we took. We found that the coefficient of x squared is 240, and the coefficient of x cubed is negative 160. Here are the key takeaways from this problem. First, always use the general formula for a term in the binomial expansion. This is your most important tool. Second, be meticulous when identifying the terms a, b, and n from your expression. Pay special attention to negative signs, as they are a common source of error. Third, set the exponent of your variable to the power you need, and then solve for k. This value of k is what you'll use for the rest of your calculations. And finally, calculate everything carefully. Break down the binomial coefficient, the powers of a, and the powers of the sign into separate parts to avoid mistakes. Following these steps will allow you to find the coefficient of any term in any binomial expansion without having to do all the multiplication.